Hi everyone, I'm about to now just do the solutions to the practice test for the review of the prior knowledge. Alright, so I've designed it as in paper 1, paper 2, and each paper has two parts, part A, part B. And remember, paper 1 has no calculators, so we're going to try to do this without any calculators whatsoever. Okay, so part A vertical line has the coordinate 5, 4. Write down the equation of this line. So I think this might have thrown some people off right to begin with, but a really good idea is always to draw a diagram. So for example, here we go. For example, let me just draw a straight line down, straight line. So this is my x-axis, this is my y, and there's basically a point 5, 4. So let's just say that's 5 and that's 4, and here's the coordinate right there. So what I just said was there's a vertical line that goes through that. So remember, when we express vertical lines, it's always x equals something. So in this case, it's x equals 5, since it goes through the x coordinate of 5. So write down the equation of this line. The answer to this is simply x equals 5. And that's it. That's all you need to write in order to, especially because it said write down. If you ever see the term write down, it just means as long as you give the solution, you get full marks. You don't even need to show work. Okay, so now the second part. Write down the coordinate of the point where this vertical line, sorry, it's a typo, this vertical line intersects with the x-axis. So this vertical line intersects with the x-axis right there. This is the x-axis right here. So it intersects it at it right there. Sorry, excuse that first red dot. So right there. So that point is simply 5, 0. So write down the coordinate where this intersects with the x-axis. It's simple. It's just 5, 0. Okay, let's move to the second part. Another line L has an equation, and now this I think threw some people off too. There's another line L that has this equation. This is still part of the same question, right? This is not a new question. It's still part of the same question. So carry on as if with the information from before. Okay, so another line has the equation 2x plus 3y equals 4. Find the point of intersection between this line and the vertical line. So what they're really saying is that there is some other line, that sort of, I guess, intersects with the vertical line. So we want to find the point of intersection. So remember that we have x equals 5. So in other words, we have one of the coordinates of this point of intersection, which is x equals 5. So all we have to do is plug in x equals 5 into this equation, and then we can find y, and then we can solve for it. So in other words, this is 2 times 5, because that's the vertical line, plus 3y is equal to 4. This is 10 plus 3y is equal to 4. If I write this over here, and I subtract 10 from both sides, is equal to 3y is equal to negative 6, and therefore y is equal to negative 6 divided by 3, which is negative 2. So the coordinate is 5, is x equals 5, and y equals negative 2. So the coordinate itself is 5 comma negative 2, and let me just get some more space. So this is our solution. So find the point of intersection. This is it. Okay, find the coordinate where L intersects with the y-axis. So if you think about it, let's just go back to the diagram. Here's the y-axis. The equation of the y-axis itself, is, once again, the y-axis is a vertical line. So it's x equals 0. Oops, let me just write that a little better. It's x equals 0. So here's the equation of the y-axis. So we want to find out where this blue line intersects with the y-axis, and so since we know that's x equals 0, that's all we have to do and plug that into this equation right here. So let me just use some white. So therefore, it's equal to 2, 0, because that's where the y-axis is, plus 3y is equal to 4. This goes to 0, so therefore 3y is equal to 4, and therefore y is equal to 4 over 3. And remember, we got this by plugging in x equals 0 for x. So in other words, the coordinate is 0, 4 thirds, and that's our answer for 1D. Now, this one should be an easy one. Expand 2x minus 6 squared. So if you remember, this is equal to 4, let me just do that again. This is equal to the first term squared plus, sorry, let me just do that. Actually, hold on 1 second. So let me just start again. So this is equal to the first term squared plus the last term squared. And the middle term is basically, you keep the same sign, so it's negative 2, sorry, let me just use a red color, 2 times the first term, which is 2x, times the last term, which is, all right, let me do this again. Let's just start. Okay, so number 2. So we have to expand this term 2x minus 6 squared. So this is a very easy question, and the way to do it is, let me just actually switch the colors here. Okay, so so the way to do it is, you take the first term and you square it, and the last term and you square that, and the middle term is just basically plus 2 times the first term times the last term. Okay, so that's always the structure when you're expanding for a square. You take the first term and you square it, and you take the last term, which is negative 6, and you square it, and the middle term right here is always 2 times the first term, which is 2x, times the last term, which is negative 6. So this squared is 4x squared. 2 times 2x is 4x. 4x times negative 6 is negative 24x. And then negative 6 squared is always positive 36. And that's the solution. Okay, number 3, solve for x. So here we have a right angle triangle. One side is x plus 2, the other side is 4, the other side is 7. So first things first is always identify the hypotenuse. And the hypotenuse is always right across from the right angle. Okay? So that means it's x plus 2 squared plus 4 squared is equal to 7 squared by Pythagoras. So if I go back here, it's x plus 2 squared plus 4 squared is equal to 7 squared. So you might be tempted to expand right here, but don't. We're trying to solve for x. There's an easier way. Subtract the 4 square first. So leave it as in that sort of factored form. So it's equal to 7 squared minus 4 squared, which is really equal to 49 minus 16, which is equal to 33. Now, so once again, this is, I'll just rewrite this as x plus 2 squared, and this is x plus 2 squared. Now we want to get rid of that squared. So the best thing we can do right now is actually just square root both sides right here. So by doing that, this gets rid of that squared. So what are we left with? We are left with x plus 2 is equal to the square root of 33. And since it's equal to the square root, now we just want to solve for x. So x is equal to the root of 33 minus 2. And since this is a paper 1 question, this is all you'd be asked for. Obviously, you cannot do the square root of 33, so you just leave it like that. This is your answer. Okay? Number 4. Now fill, okay, let me just, there's not much room here, so let me just see if I can, well, okay, I'll have to go up a little bit. So let me just do this first. So fill in the appropriate numbers into the, the following numbers into the appropriate regions of the Venn diagram. So let me just scroll down a bit, and these are the numbers. Oh, this is supposed to be pi, by the way. I don't know why it didn't show up, but okay, that's supposed to be pi. So it's negative 1, 7/8, 2, pi, and 3. Right? So here's our Venn diagram. Here we have the integers, here's the natural numbers, here are all the rational numbers, and the whole thing here is the set of the real numbers. Now if you remember the diagram from before, like the natural numbers really fit inside the integers, right? So in other words, all natural numbers are part of the integers. So if you look right here, here's where we have the integers, and here where we have natural numbers. So basically, what we're saying right here is that there are some natural numbers, like this section right here, there are some natural numbers that are not part of the integers, which cannot be, because we said from before that the natural numbers are part of the integers. So we can safely say that there is nothing at all in this section. Okay. Then we said that the integers are all part of the rational numbers, so which is q. So in other words, if there's anything that is an integer, so for example, this is z, this is the integer set, that is not part of the rational numbers, then it can't exist. So basically anything here cannot exist at all. Like, in fact, all of this can't exist, right? And also, like we said, this section here is part of the natural numbers, which is not part of the integers, so nothing can exist here as well. Okay, because the natural numbers have to be inside or part of the integers. So really, we just have this section, this section, this section, and maybe anything outside there. So let's look at the first number. Is -1. So basically, is -1 an integer? Yes. Is it a natural number? No. So -1 fits beautifully right here. Okay. So let's look at 7/8. 7/8 cannot be an integer, can't be a natural number because it's a fraction. So it has to fit right here into the rational numbers. So we're done with this, we're done with that. Number 2 is a natural number, which also happens to be an integer. So in other words, this sort of intersection right here, this little intersection right here, here's where the 2 would fit in perfectly. Now pi is not a rational number, right? So it doesn't fit inside Q, it has to go outside, but it's part of the real numbers. So pi would go here. And the number e, it's also known as the natural number, it is an irrational number, so once again, that would go here. So that, therefore, we've sort of fixed, so we've sort of determined where all these numbers fit in this diagram. So remember that the natural numbers fit inside the integers, which fit inside the rational numbers. So I will, you should be observant of how these Venn diagrams fit, because some of these will never ever work. There will be some numbers that never ever work. So basically, they'll always be empty. So just be careful. All right, so number 5, the function f is shown below. So here's the function, here's this point. There are 3 open circles right here. This point is -2, 2. This point is 5, 4. This point is, oh, actually, you know what? I should have drawn this in red. This should be in red. That should be in red. This point over here, the red point, it's a closed circle, and it's at 5, 6. So it's right above this open circle, which is at 5, 4. And then finally this point over here, which is an open circle, is at 8, -3. So the first question states, find the domain of f. So remember, recall that the domain is sort of the x direction, right? So if we draw a number line here, if we look at number 2, that there's nothing over there. So, but then we keep on going, we keep on going. We might think that at number 5, we see an open circle. We might think that, oh, let's put an open circle here too. But remember, we see another point that is valid. So we cannot put an open circle here. So this is a closed circle right here. And finally, we keep going, we keep going, we keep going, and then we see 8, and there's nothing here. So therefore, it's an open circle over here. So really what we have is all this region between -2 right here and 8 over here. So the domain of f is really, we say x is, oh, let me just use white. So, so the domain of f is really x is element of reals, right? And we say it's between -2, right? And it does not include 2, so we're not going to put an equal sign, x, and it goes all the way to 8, and it doesn't include 8, so that's why we're not going to put an equal sign right there. The next question says to find the range of f. So let's actually just go back to this, and maybe I'll use yellow, and maybe yellow will be a bit better. So now let's look at it from this direction. So we can see that 6, oh, well, actually let's start from the lowest point. So we can see that -3 is not included. So there's an open circle in -3. So we keep going, we keep going, we keep going, we keep going, and then we see that, okay, there's an open circle at 2, so we might be tempted to think, oh, there's an open circle, but remember, there is also another point right here, which is valid, so we cannot put an open circle right here. So for 2, it's just simply a closed circle, so we don't even have to worry about that. Okay, so we keep going, we keep going, we keep going, and then, oh, look at 4. 4, there's an open circle right there. So there's an open circle right there, so, and there's no other point, so that's why that's an open circle. There's nothing else here, but then there is a dot over here at 6, right? So in other words, we include 6, but nothing else in between. So if we were to shade this, we would include everything from -3 all the way to 4, and then we would also have to include 6 because there is a closed dot right there. So how would we write the range? So I'm just going to write it here instead of down there. So first we would say y is element of reals, right? And then the condition is that it goes from -3 to 4, right? There's no sort of gap in here. So it's -3. Are we including -3? Absolutely not, because there's an open circle. So y, and so it all goes all the way to 4, right? And then we say or, right? Or because like there's one more point that we have to include, which is y equals 6. And it's just only equal to 6. There's nothing less than or greater than or anything like that. It's only equal to 6. And therefore, this is the range of this function. Okay, now part B. This is the interesting part. So part B, so one more thing I just want to say is that whenever you're doing these questions, part A is designed to be done really quickly, so you have more time to do part B. All right, so let's start with part B, number 1. The Alpha Rental car rental company rents out their cars at a fixed initial rate of 50 plus 30 cents per kilometer. The Beta company rents out their cars at fixed cost of 30 plus 50 cents per kilometer. For both companies, cars have to be serviced after 1,000 kilometers and must be returned to a local rental depot. All right, so let's start this. Okay. So the first question says, I just need to extend the page a little bit. So the first question says, write down the cost of renting a car from the Alpha Rental Company in terms of the number of kilometers driven. So C is the cost right here, and D over here is the kilometers driven. So we need to write down an expression that expresses how much the cost would be depending on the kilometers driven. So let me just switch colors here. So C, so for the Alpha Car Rental Company, is we basically charge 50 plus 30 cents per kilometer. So here's our rate, and here's our fixed cost. So really C is, it's really 30 cents per kilometer driven. Remember, D stands for the number of kilometers driven, plus 50 cents, or $50, sorry, for just, the initial cost of renting the car. And this is it. This is all that we need, because it just said write down an equation, write down C in terms of D, and that's it. Okay. Now B, write down the cost of renting from the Beta Rental Company in terms of the kilometers driven. So if we just look back at the question again, let me see if I can scroll down a bit. If we look back at the question again, for the Beta, we see that it's $30 is the upfront cost plus 50 cents per kilometer. So this is our rate, and that's the upfront cost. So in other words, for B, for the Beta Rental Company, it's C is equal to 30, because that's the upfront cost, plus 0.50D, and that's the rate. Or I could have just written it as 0.50D plus 30. It doesn't really matter. 1 plus 2 is the same thing as 2 plus 1. So 0.5 is 30 plus 0.5D is the same thing as 0.5D plus 30. And this is it. This is the solution that we have here. If you had written either one, you'd have gotten full marks. Okay, so C, find the cost of renting a car where it is economically neutral to choose either company. So it's kind of a vague language, but what it really means is find basically the cost where it doesn't matter really which company I go with, because the cost is going to be the same. So if the cost is going to be the same, that means C is going to equal to C, right? C from one company, the cost of one company is going to equal the cost of the other company. So from the Alpha company, if we just go back, what the cost was it was 0.30D plus 50, right? That was from the Alpha. This is like Alpha. This is Alpha. Okay, and from the Beta, it was 0.50 cents, so it was 50 cents per kilometer plus 30, right? So this is Beta, right? So we need to find the cost. So in order to do that, first we have to basically solve for D, and then we can come back to the cost. So really, if you think about it, it's just, this is one line right here, and that's another line right here, and really what we're trying to find is the intersection of the 2 points. So what I basically did, this method is the substitution method. You could have done the elimination method, it would have been fine too, but I'm just going with the substitution method because it seems straightforward. So I can I can subtract the 0.3D from this side or that side, and then I can subtract the 30 from this side to that side. So really it would be 50 minus 30 is equal to 0.50D minus 0.30D. So in other words, 20 is equal to 0.0D. or let me just rewrite it the other way, is equal to 20. So what I can do right now is d is equal to 20 divided by 0.20. So I think some people had some issues with just dividing this, but one simple way of dividing this is you can multiply the top and bottom by 10, right? So if you multiply the top by 10, it becomes 200. And if you multiply the bottom by 10, the decimal point moves 1 to the right, so it becomes 2. So it's 200 divided by 2, which is equal to 100. So in other words, if you drive 100 kilometers, it's economically neutral. It doesn't really matter which car company you go with. So, but the question said find the, let me just scroll up a little bit. The question said find the cost. So we're not interested in the distance driven, we're interested in the cost. So in order to find the cost, we just basically pick any of the equations. So let's just pick the alpha company, for example. So the alpha company was 0.3d plus 50. We know that the number of kilometers driven to make it neutral is 100, so just plug that in. So 0.3 times 100 plus 50, so that's equal to 30 plus 50, which is equal to 80 bucks, right? So if you're willing to spend 80 bucks, or sorry, if you're going to drive 100 kilometers, then basically the cost is going to be 80 bucks, and it doesn't matter. Both companies will cost 80 bucks if you go 100 kilometers. All right, so then this is the last part of this question. Write down the range of costs for the alpha car rental company. So the range of costs, that means what's the lowest cost and what's the highest cost. So remember, let's just go back to the question. It said, for both companies, the cars have to be serviced after 1,000 kilometers and must be returned to the local depot. In other words, we must stop the car when we reach 1,000 kilometers, right? So for the alpha car rental company, let's just write their equation down again. So C is equal to 0.0d plus 50, right? So in other words, if you don't drive anything at all, let's say, for example, d equals 0, okay? That means you're basically starting. If d equals 0, then C equals 0.30 times 0 plus 50, which is equal to 50. So this is your lowest cost, right? This is the lowest cost that you're going to incur. You have to pay 50 at least, even if you don't drive anything. Now, the most you can drive is 1,000 kilometers, because I just said that. It was stated in the question. So let's see what the maximum cost will be. So the maximum cost will be 0.30 times 1,000 plus 50, which is equal to, this is 300 plus 50, so which is equal to 350. So in other words, the lowest cost is that, the highest cost is that. So if we look at the range of costs, C is in between 50, right, and 350. So the range of costs is really between $50 to $350 for renting from the Alpha Car Rental Company. All right, so second question for part B. This was, I believe, this is a little bit tricky, I will admit. So let's sort of look at the information and see how we can figure out from this triangle and the information given how we can figure out x. Okay, so basically it says sine 30 degrees is equal to half. So you're given that. So that means the ratio of the, remember, sine stands for opposite over hypotenuse, opposite over hypotenuse. So O over H. So sine of 30 degrees is 1 over 2. So the ratio of the opposite of a hypotenuse is 1 over 2. So let's take a look at this triangle. If we see this triangle, we see 60 degrees, we see 45. I don't see 30 anywhere. But if you remember, the sum of all three angles in a triangle is 180. So if this is 90 degrees and that's 60 degrees, what that means is this angle right here is 30 degrees. Okay? So you're supposed to kind of just figure it out. You're supposed to know that all three angles in a triangle must add up to 180. And if you add up all these three, they become 180. So therefore, this has to be 30. So what we're going to do is, the first thing we're going to do is just take a look at this triangle right here, right? So I'm just going to redraw that triangle right there. Okay? And this is 10 root 3, and this is 30 degrees. Okay, so we don't know the measurement of this length, neither do we know the measurement of the hypotenuse, right? But what we do know is that the ratio of the opposite, so the opposite is this side right here, to the hypotenuse, which is this side right here, this is 1 to 2. So in other words, if this is 1 centimeter, this length has to be 2 centimeters. If this is 5 centimeters, this length has to be 10 centimeters. Okay? So we don't know either of the length. So let's call this side A. Okay? So if we're told that sine 30 is 1 over 2, if this side is A, that must mean that this side is 2A. Okay, and now if we have A and 2A, we can use the Pythagoras to find out what A is, what the length of A is. So let's do that. So we have, and so this is our hypotenuse, which is the 2A side. So it's A squared plus, put this in brackets, 10 root 3, right? This is B. B squared is equal to C squared, which is the hypotenuse. So that's 2A squared. Very, very important to put these in brackets. If you don't, then you will make mistakes. So it's A squared plus. Now, when you're squaring this, what happens is each element inside gets squared. So 10 gets squared. So 10 squared is 100, right? And root 3 squared is 3, right? So it's 100 times 3. Now, if you square this, 2A squared is the 2 gets squared, which is 4, and the A gets squared, which is 4A squared. So let's try to solve this. So A squared plus 100 times 3 is 300, which is equal to 4A squared. Now, you want to bring all the A squares to one side. So I'm going to subtract the A squared from this side and equal to that side. So in other words, 300 is equal to 4A squared minus A squared, which is 3A squared. I'm going to rewrite this as 3A squared is equal to 300. I just switched their positions just to make it easy. Then next, before you can find A squared, you have to divide by the 3. So A squared is equal to 300 divided by 3, which is simply 100. So in other words, A is just the square root of 100, which is equal to 10. So what that means is this side, right, so let me just redraw it. This side, this is 30 degrees, that's 90. So now this was 10 root 3. So this side is 10, which makes this side 20. Okay, so we're halfway there to solving our problem. So what we know is that this side right here, let me just do a different color. This side right here has now a measurement of 10, and this side right here now has a measurement of 20. So we're halfway there into finding basically what this x is. So now let's look at this triangle right here. So that's a 45-degree triangle. Sorry, it's a right angle triangle with one of the angles is 45 degrees. So I'm just going to scroll further down, and I'm going to redraw that triangle. So I'm going to use yellow this time. So let's redraw that triangle, right? And here we go. So this is 45 degrees, right? This is 90, and this is 10, right? And we don't know what this side is. But if you take a look at this triangle, it's a 45 degree angle here, which is 90 degrees. So the other angle right here is 45 degrees. So what kind of triangle has two angles that are, if two angles are the same, what kind of triangle is that called? That's called an isosceles triangle, which means that not only are the two angles the same, but the two sides are the same. So if we just determine that this is 10, we already know that this is 10 as well, like this length here is 10 as well, because it's a 45, 45, 90 degree triangle. In other words, it's an isosceles triangle. So because it's isosceles, and we have two sides, now we can find what x is, right? By simply using Pythagoras again. So I'm just going to use white this time. So now it's 10 squared plus 10 squared is equal to x squared. 10 squared is 100, so in other words, it's 100 plus 100 is equal to x squared. So it's 200 is equal to x squared. And so finally, what that means is, I'll just write x squared is equal to 200. So x is equal to the square root of 200, and that's it. Remember, this is a paper 1 question. You're not expected to find what this is because you can't. You need a calculator to solve what this is. So if it's paper 1 question, just leave it in this term. Just leave it in this fashion. So we're done. Now, moving on to paper 2. Remember that calculators are allowed in paper 2, and use it if you need it. And once again, paper 2 is designed, it's split between part A and part B. Try to finish part A as fast as possible so you can spend more time on part B, which is generally a little bit more difficult. All right, so number 1, find the point of intersection of these two lines. So we can do this either using substitution or elimination, But if you want to do substitution, or if you want to do elimination, sorry, you have to make sure that the variables and the constants and everything is lined up. They are not lined up. It's the x and y and x, but the constants are. So the first thing we have to do is just switch everything, such that everything does line up. So it's 2x minus 3y is equal to 14. And this is going to be negative x plus y is equal to negative 6. So the next thing we need to do is we need to make sure that the x's have the same number but different signs. So in order to do that, let's say I want to eliminate x, I'm going to multiply the second one by 2. So because I want to make sure that this is 2x and this is negative 2x. So if I do that, basically what happens is now my set of equations becomes 2x minus 3y is equal to 14. So I haven't touched the first one. But the second one becomes negative 2x because x times 2 is negative 2. Y times 2 is positive 2y. And 6 times negative 2 is negative 12. Right? So I line them up. And I'm just going to get some more space. So I line them up and I add them. So this sort of crosses out. So negative 3y plus 2y is negative y. And 14 plus negative 12 is 2, right? So now I want to divide by negative 1 because I want to get rid of that. So y is equal to negative 2. So I have y is equal to negative 2. Now I need to solve for x. So I'm just going to use the second equation right here since it's written pretty much right there. So it's equal to y, which is negative 2, minus x is equal to minus 6. So if I add 2 to both sides, it becomes negative x is equal to negative 6 plus 2. So in other words, negative x is equal to negative 4. And if I divide by negative 1 on both sides, I get x is equal to 4. Right? And we can sort of check. And so the point of intersection, then our actual final answer, is 4, which is the x, and negative 2. And then we close it right there, and this is our solution. And we can sort of check whether this is right. 4 minus negative 2, in other words, wait, something is not right here. Oh no, sorry, this is right. So y is negative 2. See, I got fooled by the rearrangement. So y is negative 2, so this is negative 2, minus 4. So negative 2 minus 4 is negative 6, and so that's correct. If we try it over here, 2 times 4, 2 times x, so that's 8, minus 3 times negative 2, so negative 3 times negative 2 is positive 6. So it's 8 plus 6 is equal to 14, and that's correct. So we know that this answer is correct. So one way of checking is sort of plugging it back in, but make sure you plug it in the right place. Like you don't want to be fooled like I just was. So make sure the y, you choose the y value, and for the x, you choose the x value. Okay, number 2. A line is perpendicular to this line, 2x plus 3y equals 5, and goes to the point 1, 1. Find the equation of L, right? So first of all, let's write this in y is equal to mx plus b form. So this is 2x plus 3y is equal to 5. I can subtract 2x from both sides. So in other words, 3y is equal to negative 2x plus 5. And then I'm going to divide by 3. So y is equal to negative 2/3 x plus 5 over 3. So by doing that, this is the equation of this line, of some line. And L is perpendicular to this line. So in other words, the slope of this line is negative 2 over 3, but the slope of L has to be the negative reciprocal. So in other words, the slope of L is 3 over 2. And we know that L goes through the point 1, 1. So we have the slope. So we have y is equal to mx plus b. So for L, y is equal to 3 over 2x plus b. It goes to the point 1, 1, so now we can just substitute and solve for it. So 1 equals 3 over 2 times 1 plus b. So 1 equals, 3 over 2 is 1.5, and 1.5 times 1 is simply 1.5 plus b. So b is equal to 1 minus 1.5, so I'm just going to rearrange it. So b is equal to 1 minus 1.5, which is equal to negative 0.5. So our solution then is for L, we have the slope, which we said was 3 over 2, we have the y-intercept, which we said is negative 0.5. So y is equal to 3 over 2x minus 0.5, and this is our solution. So it doesn't matter whether you write it as a fraction or a decimal, as long as it's the right answer, that's all I care about. Okay, so we have a right angle triangle here. It's not well drawn, but anyways, it's a right angle triangle, and we have to find the angle alpha. So let's figure this out. So remember, the first thing you want to do is always find out what the hypotenuse is. So this is your hypotenuse, right? So if this is your hypotenuse, so this is the hypotenuse, right? And what that means is if this is angle alpha, so anything that's not the hypotenuse that's touching it becomes the adjacent. So this is the adjacent, and therefore the last side is the opposite, right? So now the sides that we know are the adjacent and the opposite. And if you go through the mnemonic SOHCAHTOA, the only one that sort of works in this case is TOA. So because we have T-O-A, we have O right here, and we have adjacent right there, so we must use TOA, which is tan. So tan of alpha is equal to the opposite over adjacent, right? The opposite right here has the value of 2. The adjacent right here has the value of 7, right? So alpha then is tan inverse of 2 over 7, right? And if I plug that into my calculator, which I'm doing right now, make sure that when you're plugging into your calculator, you use degree mode. So if I plug in 2 over 7, right now I get 15.9. And you want to put it into, so normally it would be 15.9453 ... But we just wanted the 3 significant figures, and this is degrees. So this is 15.9 degrees. Okay, so that is the value for alpha, and then that's the angle. So this was a relatively easy question, designed to get you through it quickly, so you can get to part B. Now this one is a little bit tricky, but you should still be able to figure it out. Okay, so you see basically we have like 3 triangles, this big one right there. We have a small right angle triangle over here and another small right angle triangle here, and we're supposed to find x. So in order to do this, we kind of need to find out this little dividing line here. That's usually how these things work. So if we find that one, then we can hopefully find x. So I'm going to basically break it apart by looking at this triangle first. So let's look at that triangle first. Right, so we have that over there, we have 4, and then we have 20 degrees, right? So let's call this side A, okay, because we don't know what that value is, so let's just call that side A. So let's try to find the value of A. So if we look at 20, right, if we look at 20, always find the hypotenuse first. So the hypotenuse is right across from the right angle, so this is the hypotenuse, right? Which means that if this is the angle, then the side that's closest to, the adjacent side, is this one right here. So this is the adjacent side, which makes side A the opposite side, because it's exactly opposite from 20, right? So what side are we playing with, or what sides are we, what values do we know? We don't know A, but we're trying to find that, and we know the hypotenuse. So we know the opposite and the hypotenuse. So if you go through the mnemonic SOHCAHTOA, we are basically dealing with SO, right? Because we have the opposite right here, and then we have the hypotenuse right there. So sine of 20, right, is equal to the opposite, which is A, when we're trying to find that out, over the hypotenuse, which is 4. So we're trying to find A. So if we're trying to find A is equal to, if we multiply both sides by 4, it's 4 sine 20, right? And 4 sine 20, I'm going to plug that in right now, is 1 point, so I'm actually going to use the exact value. I'm just going to carry over 1.3680 ... So I want to use the exact value, and because I'm using the exact value, I can write equals to right here. So we found A, which is basically this side right here. And remember, this side is shared by both triangles, okay? So I'm now going to focus on this one, which is going to help me find x. So I'm just going to take a little bit more room here. And so now if I draw the second one, maybe just draw it in yellow. Okay, so I draw the second one, which is like that. So that's the second triangle. It's a right angle triangle, we know that. We know this side is x, and this side is a, which we just found out to be 1.3680 dot dot dot, and the angle over there is 40 degrees. So this angle right here is 40 degrees. So let's ask ourselves again, which one's the hypotenuse? Again, this is the hypotenuse, HYP. This is the hypotenuse because it's right across from the right angle. And this angle, this side right here, is the opposite, right? This is the adjacent because it's touching, this angle is touching this side, so which makes this is the opposite. So once again, ask ourselves which one deals with the opposite in the hypotenuse. Using the SOHCAHTOA mnemonic, it's going to be so, because we have the opposite, right? We want the hypotenuse, right? And so that's what we're going to use. So sine 40, right, is going to be the opposite over the hypotenuse. So it's the opposite is 1.3680 dot 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 all over the hypotenuse, which is x, right? So if we rearrange this equation, basically, if we rearrange this equation, I can say that x is equal to 1.3680 dot 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 divided by sine 40, right? All I did was I basically multiplied everything by x, and then I divided by sine 40. So in other words, these two positions, this position basically switch. So the x goes here, the sine 40 goes down here, and which is what happened here. So if I find this value, it's equal to, I'm just plugging this in right now, it's equal to 2.12835 dot dot dot, and I'm going to approximate to 3 significant figures, so it's going to be 2.13, and that's my solution. So x in this case is equal to 2.13, and remember, whenever you see sort of multiple triangles, break it apart, find some unknown sides, and then use that to find whatever quantity that we're looking for. All right, so now part B. Here's the equation, or here's the question. So function g is shown below with points A, B, and C. Okay, a straight line connects A and B. So this straight line connects A and B, as well as B and C. So there's a straight line that connects B and C right there. Okay, so let's look at the first question. The first question says, find the range. It says find the range, in other words, the y value of g. So let me just use yellow here. So in other words, I'm looking, draw a number line this way. Okay, so let's look at the lowest value. So we see -3. It doesn't include C, it doesn't include that. It's an open circle, so this is -3, and there's no other point here. So we definitely know that's an open circle. We keep going up, we keep going up, we keep going up, and then we see an open circle here at 4. So we might be tempted to think that there's an open circle here, but keep in mind that there is another value right there. So we cannot put an open circle here. So this is a closed circle right here at 4. Okay, so we didn't even need to write that because it's sort of included, but this is something to keep in mind. And then finally we keep going up and we see B. This is an open circle. There's no other point, so this is definitely an open circle. So if we ask ourselves what's covered, it's everything from -3 all the way to 6. So we don't even have to worry about 4. It's from everything from -3 all the way to 6. I'm actually just going to write, excuse me, I'm actually just going to write the range over here. So it's y is element of reals, and the condition is it's from -3, it does not include -3, all the way to 6, and this is our solution for the range. So this is the solution for the range right there. Okay. Now part B, B of the same question, find the slope of AB. So in other words, find this slope right here. So in order to find the slope, remember, we have to look for the rise over the run. So if I look at this right here, okay, so this is my triangle right here, right? So what's the rise? The rise is the difference from here to here. So the difference from here to here is 2. So this distance right here is 2. What's the run? This is 5, and that's 2. So what's the distance from here to here? That's 3. So the rise of the run is 2 over 3. So you can do this 2 ways. You can say the slope of AB. So m of AB is equal to rise over run, right? and you can say, like based off the diagram, it's basically, 6 minus 4, 6 minus 4 divided by 5 minus 2, 5 minus 2. So in other words, it's 2 over 3, and that's it. That's your solution. You don't have to add or anything more than that. So remember how we got our rise over run? We just look at these 2 points. The rise was 2, the run was 3, so therefore it's 2 over 3, and that's our solution for the slope. Okay, there's actually more to this question, so let's go to the next part. So it's part C. So I just basically copied the same diagram again. Now, the segment BC is perpendicular to AB. So this piece right here, this line right here, is perpendicular to AB. So in other words, there is a 90-degree angle right here, okay? So find the x-coordinate of C. So if you observe carefully, this question does not state what the x-coordinate of C is. So we somehow need to use the information of the slope of this one to find the x-coordinate of C. So what I'm going to do is I'm going to show you the easy way of doing it, and I'm going to show you maybe the hard way that most of you guys sort of took. So we know the slope of AB, right? We just found that out, that the slope of AB is equal to 2 over 3, right? So since we know that the BC is perpendicular to it, we know that the slope of BC has to be the negative reciprocal. So in other words, it has to be negative 3 over 2, right? So that means this over here, the ratio of, so this was, sorry, let me just draw it in different colors so that way it's just clear. So the ratio from here to here, this was 2 and that was 3, right? This was 2 right there and that was 3. So the ratio of this slope, in other words, this is the rise and this is the run, should be, let me use white actually. The ratio of this one should be negative 3 to 2. So in other words, this run is negative 3. In other words, the ratio has to be from negative 3 to 2. So another way of, if you look carefully, the distance from here to here, from 6 to minus 3 is actually negative 9, right? Because it's a fall, it's a drop. We're going from down and then to the right. So from 6 to negative 3, it's actually, you're dropping 9 units. And you're dropping 9 units. So in other words, you're dropping 9 units. So if we're looking at BC, this would drop 9 units. Now the question is, if you want to maintain the same slope, how many units do you have to go to the right, right? So if we go from, say, negative 3 over 2, so in other words, I need to multiply by 3 over here, so negative 3 times 3 is negative 9. So what I do to the numerator, I must do to the denominator as well. So it's 2 times, so in other words, this is 6. So if I drop 9 over here, I need to move to the right 6 in order to get a slope of negative 3 over 2, right? Oops, I don't know what that showed up. But if I drop 9 units down, I need to move 6 units to the right in order to maintain a ratio of negative 3 over 2. So if I need to move 6 to the right, remember this point right here is 5. This x-coordinate right here is 5. So if I need to move 6 to the right, it must mean that this point right here has to be 11. Okay? It has to be 11. So if I were showing this, I would explain in this fashion that the ratio has, it's negative 3 over 2. It has to move negative 9 over 6. So since it has to move 6 more units to the right, this is 11. So the x-coordinate of C, is equal to 11. That's one way of doing it. So this was what I consider to be the easy way of doing it. I'm now going to show you the hard way of doing it. The hard way of doing it is probably what you guys did was you probably took 2 points, found the slope, found the equation of this line, or found the slope, and then since you know that this line goes through that point, you basically figured out what the x-coordinate of C is. So let me just use that approach. So let's do what I consider the hard way, right? So we know that the slope of AB is equal to 2/3, and so you can deduce that the slope of BC is negative 3 over 2. So in other words, m of BC is negative 3 over 2. So you can find the equation of the line if you want. So y is equal to mx plus b, right? And so you know it's y is equal to negative 3 over 2x plus b. So next we need a coordinate it goes through, and since we know that it goes through b, the coordinate of b is 5, this is 5 right here, and 6. So the coordinate of b is 5, 6. So you can just plug that in right here. So the coordinate of b is 5, 6. So this is 6 is equal to negative 3 over 2 times 5 plus b. Let's do this. So 6 is equal to negative 15 over 2 plus b. So b is equal to, you can add that, so plus 15 over 2. So 15 over 2 is 7.5, and 7.5 plus 6 is 13.5. So b is equal to 13.5. So the equation of this line, of a line that goes through b and c, is now y is equal to negative 3 over 2x plus 13.5, right? The question said, find the x-coordinate of c, right? So in other words, we know the y-coordinate of c is negative 3. So if we know the y-coordinate of c is negative 3, we can just plug it into that equation to get what the x-coordinate of c is. So let's use this equation again. We know that the y-coordinate of c is equal to 3. So it's negative 3 is equal to negative 3 over 2x plus 13.5. Negative 3 over 2 is just basically negative 1.5. So negative 3 is equal to negative 1.5x plus 13.5. I can basically add 1.5x to both sides because I want this to be positive, and I can add 3 to both sides because I want this to be positive as well. So basically 1.5x is equal to 3 plus 13.5, and I just need a little bit more room. So 1.5x is equal to 16.5, and x is equal to 16.5 divided by 1.5. And because this is a paper 2 question, you can just divide that using your calculator, and you'll get 11, which is exactly what we want. So the x-coordinate of that point C is now 11. And that's how we solve for C. Okay, so hence or otherwise find the domain of G. So we have just found out that this point right here is 11, right? So now we can basically just use this information to find the domain of G. Now if we look at A over here at 2, this value 2 right here, there's an open circle. So we can't really do much about that. And so we move to the right, move to the right, move to the right, and we see another open circle, and there's nothing else in it. So there's another circle right at 5, this 5 value here. And we keep going over here, and then once again we see another open circle at C, which is 11. So in other words, if we were to shade this, it's everything here and everything here. So there are 2 segments, from 2 to 5 and from 5 to 11. So the domain, right, you would write x is element of reals, and what you would say is it's from 2, and it's not including 2, all the way to 5, or, so it's from 2 to 5, or it's from 5 to 11. So it's 5, so x is in between 5 and 11. So what this means is x is right in the middle of 2 and 5, and here x is right in the middle of 5 and 11. And that's how you do that. Okay, so the last question of this section is the following. A vertical line goes through the point -2, -3, and a horizontal line goes through the point 5, 4. Write down their point of intersection. So a really good idea when you have questions like these is to really draw a diagram. So we have this is our x-axis here and our y-axis there. So a vertical line goes through point -2, -3. So -2 here and -3 here. So -3. Let me just draw that a little bit better. So that is -3. So we have a vertical line that goes right there. And so remember how we write vertical lines, x is equal to -2. Now we have a horizontal line that goes to the point 5, 4. So we have 5 over here and 4 over there. So that's the point right there. So we have a horizontal line that goes through 5, 4. And the way we describe this line is y is equal to 4, right? Because it's the y component. That's how we describe horizontal lines. So the question is, what is this intersection point? So this intersection point is x is equal to -2 and y equals 4. So our solution then, to write down the point of intersection, is really -2, 4. And that's it. Now, the line L, 2x minus 3y equals 8, intersects the vertical line. Find the point of intersection. So in other words, there is some line, which is this equation right here, and it will intersect the vertical line. So in other words, it most likely goes something like this, right? And I'm just going to extend the horizontal line like that. So what we're looking for right now is the point of intersection right there. So we know that x equals -2, so all we have to do is plug that in right there and solve for y. So if I do that, it's 2 times -2, because x is equal to -2 right here, minus 3y is equal to 8, right? So I can solve that as -4 minus 3y is equal to 8. What I can do is I can add the 4 to both sides, so it's -3y is equal to 8 plus 4, which becomes 12. And then if I do that, y is equal to 12 divided by -3, which is equal to -4. So my coordinates are -2, which is x, and y is equal to -4. So the point of intersection then becomes -2, comma, -4. So this is my solution for the point of intersection. Now, the last part of this is the intersection of all three lines forms a triangle. Find the area of the triangle. Okay, so what does that mean? So, well, and the hint over there suggests to draw a sketch. So it's really, really important to draw a sketch. So we have kind of a sketch like that. So if you can see, there are three lines. There's this vertical line, horizontal line, and then this line over here. And they form this section right here, which is a triangle. So in order to find like what the area of the triangle is, it's really important that we know all these sort of intersection points right here. Okay? So we have this intersection point, which we've determined to be -2, 4. Okay? We have that point, which is we determined to be -2, -4, right? But we don't have this intersection point. So in other words, that's where the horizontal line meets the line L over here, the blue line over here. So we have to find that intersection point. But we know y equals 4, so we can plug that in over here and figure out what the x-coordinate of that intersection point needs to be. So let's do that in a second. So once again, our equation of the line is, what was it? 2x minus 3y. So it's 2x minus 3y is equal to 8. It was 8 or -8? It was 8, yes. And we said that we want the horizontal line, so we want to find where the horizontal line intersects. So y is equal to 4, that's the horizontal line. So all we have to do is plug y equals 4 right here. So 2x minus 3 times 4 is equal to 8. So 2x minus 12 is equal to 8. And it's 2x is equal to 8 plus 12, which is equal to 20. So x is equal to 20 divided by 2, which is equal to 10. So our point of intersection is 10, it's equal to 10 comma 4, right? 10 comma 4. So in other words, this point right here is 10 comma 4, okay? This point right here is 10 comma 4. So what I'm going to do right now is I am going to see if I can copy this. Bear with me for a second. So I'm going to see if I can copy this. I'm just going to, just give me 1 second. Put this as a group. Okay, and copy. And I'm just going to show you how we're going to find the, let me just do that right here. Oops, should be right here. Edit, paste. Right, so right here. So basically this is our picture right here. Okay, so we need to find the area of a triangle. Now if you recall what the area of a triangle is, the area of a triangle is equal to half times base times height, right? And the base and height need to be perpendicular to each other. Now, we know that this is a vertical line, we know that this is a horizontal line, and they definitely meet at a perpendicular, they're perpendicular to each other. So what we need is this length right here, and we need this length right here. So if you observe, this point is -2, 4, and this point is -2, -4. So in other words, since they're on the vertical line, that's 4 and that's -4. So this distance right here is a distance of 8. If you go from -4 to 4, so that's if you go from -4 to 4, that is a distance of 8. So we have this one side length of this triangle. Now if we look over here, this is -2, 4 and 10, 4. So in other words, and they have the same y coordinates. So really what we need is the distance. So from -2 to 10, so the distance from -2 to 10, so from -2 to 0 is 2, and from 0 to 10 is 10, so it's 2 plus 10. So the distance from -2 to 10 is 12, right? So we basically have the base, we have the height of this triangle, and now we just need to plug that in. So it's half times 8 times 12, which is equal to 4 times 12, which is equal to 48 square units. It's very important to put square units for this. All right? So anyways, that's our solution for this question, and this was the last question of the test. This was, I think, a little bit challenging, or could be a little bit challenging, but the best suggestion I can give is always draw it out. Always draw a sketch. When you draw a sketch, things become so much clearer. But if you don't draw a sketch and you sort of try to do it in your head, you may get it or you may not get it. So that's my suggestion, and that's this practice test. I'll see you next time.